Alright, hey guys. If you're watching this, I hope you find it helpful. I'm just recording this as obviously I couldn't be there for a few lessons this week to try to help you guys be as prepared for your test as possible. So this is just the practice test that you guys should have gotten in class on Tuesday. If you didn't get a copy, there is like digital copies of the files up here and here, depending if you want PDF or Word, or you can obviously just scroll through the OneNote and it's right there. Alright, so I'm just going to put up my solutions on this one here. Alright. Now, the way the file's uploaded to OneNote, it's sort of cut part C and D off a bit. Like, you can see the image here is over the top of this other one. So, you guys will have to look at your printout to see exactly what those other triangles look like. But from what I recall, if S is scaling, I is isosceles, E is equilateral, we should have that A is a scaling, all three sides different, B is a scaling, all three sides different. From what I recall as well, C should also be scaling, but it's got a right angle in it as well, worth noting. And then part D, I believe, all three sides were 10 meters, which would make that equilateral. This one here, the three lines tell us that it's equilateral. And then, last but not least, we have an isosceles, because two sides are equal. Alright, nice and easy to get you guys started. We are asked to sketch the following prisms, hexagonal prism, and a pentagonal prism. So look, hexagonal prism is going to have 6 sides on the face, and pentagonal is going to have 5. Alright guys, to draw the hexagonal prism, the way I like to start it is by, so can't stress this enough that if you have a ruler or grid paper or, isometric dot paper, they're obviously much better tools, but given I've only got the iPad here, I can't, and for whatever reason, when I try to do straight lines, it just sends me to the other side of the OneNote. So, because of that, where did it just put that line? Hopefully that's not blocking anything. Anyway, so I'm limited by my tools, but I'll still give it my best shot to show you guys. So I sort of start with 3 equal length parallel diagonal lines, and then halfway between the first ones we're gonna throw in a couple of dots at either end that should make it should connect up to make a hexagonal shape. So we should be able to join these up to get something that resembles a hexagon there. And now we're going to connect this one with this one, this one with this one, and we're going to throw this one here slightly short and then connect it up with there. And then we're going to throw this one out slightly short, connect it up with that one there. And then if we've got some dotted lines, should look a little bit like that. 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 Alright, so not the best. Once again, if you had a ruler, you could make it a little bit more accurate. But obviously we've got that 6-sided, 6-sided face, and then protruding evenly backwards. Alright. Time for a pentagon. Alright, so for the pentagon, the pentagonal prism, sorry. I'm going to start by drawing a pentagon at the top here, which is a skill in itself. Much easier, once again, if you do have a ruler, but still a bit of a challenge. So let me go for a line around about there, kicking out to about there, joining up to the top there. So that hopefully roughly resembles a pentagon. And then we're going to come down in equal length straight lines here and here and connect them two up. And then these ones on the sides here, we're going to come a little bit shorter come down a little bit shorter. And then if we want, we can also do the dotted lines at the back. Don't necessarily have to, but we would have dotted line coming down to about there, going out to there, and across to there. Cool. One pentagonal prism and one hexagonal prism. Question 3. A screen on a handheld device has dimensions 9 centimeters by 6 centimeters. What is the diagonal length in x in centimeters? Hopefully we can recognize that we have a right angle triangle there. And as such, this is the hypotenuse side. When we're solving for the hypotenuse side, we would look, we've hopefully written this down in our page of notes, and we would look and use this formula. And I'm going to replace C now with H. And I replace 6 for A, 9 for B. Actually, I'm just going to throw that straight into my calculator. Throwing that in the calculator gives me 10.81. Meters. If you read the question carefully, though, it asks for the answer in centimeters. So, multiplying that by 100. And I still had the round, like the unrounded version of the calculator, hence where I picked up the last 2 decimal points there. Cool. Alright. Question 4. Fiona's house has the outer dimensions as shown in the diagram below. Calculate the height of the house h to 2 decimal places. So for this one you'll see, so our goal is to find this height up the middle here, right? And we've already kind of got this first bit here. We've already kind of got this first bit here, right, to there-ish as, well, 3.5 meters. So then it's just this height, this remaining, or this like remaining solid orange height here that I need to find, which you'll notice is embedded into a right angle triangle. So if I redraw said triangle, we've got 4.9 meters on the hypotenuse, and this bit here, from there to there, is half of that 9.2, so that should be 4.6 meters. And we're trying to solve for this bit here. So you guys probably recognize that that is the hypotenuse. So I can even label that with a C because it's going to be Pythagoras. This is going to be my A, and I'm labeling this as my B only because this is the unknown side, right? So if we looked at our page of notes, we would have noticed that the formula we use when we're solving for a short side is B equals the square root of C squared minus A squared, which becomes 4.9 squared minus 4.6 squared. Chucking that one in the calculator, we're going to get 4.9 squared minus 4.6 squared. Alright, sort of rounding to 2 decimal places there. I've got 1.69, and then the units here are meters. Cool. So then to find the total height up the middle here, from here to here, it's going to be this 3.5 plus my unknown amount. So my total height, h, is equal to 3.5 plus 1.69. .19 meters, and that's rounded to 2 decimal places. Cool. All right, there is a 39-degree angle from the top of the NJ building, which is 300 meters high, to the top of the LS building. The diagonal distance between the tops of the two buildings is 200 meters. What is the height of the LS building? So we're asked to find the height from here to here, right? And we already know from here to here, from the height of the NJ building. So what I need to do is find the height from here to here and add that on to this 300 meters down here. All right, so we're sort of going to extract that right angle triangle out, just redraw it. 200 meters, 39 degrees. It's come out a little bit rough. Let's make that a bit bigger. 39 degrees, 200 meters. Cool. And my goal is to solve for this bit over here. So we've got an angle and a side, which tells me that we are using trigonometry. So we are going to label as such. This is the opposite side. This is the hypotenuse side. If I now go to my, trusty SOHCAHTOA, I can see I have O and H, which tells me that we're using sine. Okay. I would strongly recommend, by the way, writing those SOHCAHTOA pyramids into your page of notes. Okay. But yeah, what you should find, we have a pyramid with sine here. I'm just trying to remember now. Is it opposite over hypotenuse? Yep. Yeah, should be. So, based on this, we're going to be covering the opposite side. So, just signifying that with my highlighter, with our thumb, because we're solving for that side, right? That's the side that we're solving for. And then we use that to start our equation. Because the remaining parts of the pyramid are side by side, we're going to be multiplying them together. So it's sine of theta multiplied by the hypotenuse. In this case, the opposite side is what we're solving for, right? And we have the angle as 39, and then we're multiplying that by 200. So that bit that I'm solving for is going to be sine of 39 times 200. .125.86 meters. Doesn't look like we have any rounding requirements this time. Cool. Yep. So then the total height, once again, is going to be that 125 we just found is the bit from here to here. So it's going to be this 300 plus the 125. So total height of the LS building, 300 plus 125.86. So yeah, once again, didn't ask for like to the nearest meter or anything like that. So I'm just going to round to 2 decimal places, as usually that's what it'll say at the start of a test. But make sure you guys check the one you get tomorrow. See what it says. Cool. All right, next question. A playground is shown on the right. First job is to draw a side view sketch of the slide and label with a vertical height of 300 centimeters. So I'll try using my shapes again, but it usually gets a bit upset with me. Okay, that's not the shape. Yeah, no, it doesn't like it. All right. No matter, we'll just have to, you guys will just have to deal with me not being able to do perfectly straight lines, sorry. Okay. There we go, side view of the slide, and there's the floor at a 90-degree angle. The vertical height is 300 centimeters. The angle between the bottom of the slide and the ground is 20 degrees. We're asked to calculate the length of the slide. Show full working and include units. So we have opposite, hypotenuse. So once again, we're going to be using sine. It's the part of SOHCAHTOA. Because we got opposite and hypotenuse. Just a reminder, you should have your pyramids handy with O, H, and sine. Solving for the hypotenuse this time. So this is the one that I'm going to cover and start my equation with. So H equals, and because it's O on top, O is going to be divided by sine of theta. All right, making my substitutions. Hypotenuse is the unknown side. The opposite side is 300 centimeters, and the angle is 20 degrees. So we get that the unknown side is equal to 300 divided by sine of 20. .877.14, and the units this time are centimeters. Calculate the length of the slide, show full work and include units. Yeah, so once again, no rounding advice, so we're just going to round to 2 decimal places. Cool. All right, the width of the roof is 600 centimeters, and the vertical height from the center of the base to the apex is 250 centimeters, as shown. What is the size of the angle at the apex, the top angle of the roof? So they're asking for this angle in here. So what we can do is we can extract this, or either or, right? But this right triangle here. Right, once again, I apologize for my dodgy straight lines. That right triangle there, and use this to solve for this angle up here, because that will be the angle up here, which will be equal to that angle there. So if we find one side of the angle, then we can double it to get that total angle for the apex of the roof. Okay. We're told this is 250 centimeters or 2.5 meters, and then the entire base is 600, so half of that's going to be 300 for this triangle here. Because just a reminder, I'm just sort of using this bit here. All right. So we've got to solve for an angle. We're using trigonometry again. Let's quickly label our triangle. We got opposite, we got adjacent. So that means we're going to be using tan, right? It's the TOA, part of SOHCAHTOA. If we go and look at our trigonometry pyramids, we should find it looks a bit like that. And because I'm solving for the angle, I'm going to cover the tan part with my thumb and start my equation with that. So I'm going to start my equation with tan of theta equals opposite divided by adjacent. And we'll leave that left-hand side B for now, but on the right-hand side, I'm going to replace O with 300, A with 250, which you don't have to evaluate this first, but I think it'll be nice and easy to process for some of us. So we're just going to evaluate that as 1.2, right? Doing the 300 divided by 250. And now remember, if we want to solve for the angle, right, we want to get it by itself, we need to do inverse tan. So that's like shift or second, some sort of button, and then the tan button on your calculator. So we should have theta equals tan inverse of 1.2. And let's see what that gets us. 50.19 degrees. Just going to check what kind of accuracy they're looking for. No, just says what is the side of the angle. So that's theta, which is just half of the total angle. So the total apex angle is 50.19 times 2, which is equal to 100.38, or technically if you keep the rounding from the calculator, it's actually 39 degrees. Cool. Alright, I believe this is the last one. Yep. The keyboard length is shown as 10 centimeters in the drawing. The actual keyboard length is 40 centimeters. Determine this scale as a ratio. So we have 10 centimeters is to 40 centimeters. If we were to simplify this by dividing both sides by 10, we would work out that this is the same as saying 1 is to 4. Using the scale from part A, determine the actual width of the keyboard if the drawing width is 5 centimeters. So before, what we'll probably find is that they were referring to this length here as 10 centimeters, and now they're calling this bit here as 5 centimeters, and we're saying if that's what it is on the drawing, what's it going to be in real life? Well, if we take our scale, 1 is to 4, and I want to get to 5, hopefully you can see that to get from 1 to 5, I have to multiply by 5. So whatever I do to one side, I'm going to do to the other. We're going to multiply this 4 by 5, and we will find that the real life width of the keyboard is, whoops, just put the answer in there, times 5 is 20. So 20 centimeters. Alright, using Pythagoras, calculate the actual length of the diagonal of the entire keyboard. So they want this bit here. So we've got 5, 10, and we're asked to solve for that bit there. So I'm just going to redraw my triangle. 5 centimeters, 10 centimeters. Although, because it asks for the actual length, we might just jump straight into using the actual dimensions. So the actual length is 40, and we've just found the actual width to be 20. So we've got 40 by 20. And we are solving for Pythagoras, so this is going to be the C side. So this tells us, because we're looking for the hypotenuse, we're using C equals the square root of A squared plus B squared. And in this case, that's 40 squared plus 20 squared. Let's see what that gives us. .72 centimeters in real life. Cool, there we go. Hopefully that helps, guys. If you have any last minute questions, please feel free to email them through. Don't forget that there is the study club as well on the Wednesday afternoon if you want some last minute help for your test tomorrow. Yeah, best of luck, guys. Thanks for watching.